Okay, good morning everyone. Am I audible?
Yes, sir.
Okay, so just wait, I am starting. Okay, so a very good morning all of you. So we have discussed in our last classes, that is in advanced control system, we have started module 3, that is state space analysis. Okay, and previous class we have to discuss different definitions of the state space analysis. What is state, what is state variable, what is state vector, what is state space, and what is the state space equations. So I just recall them because last classes we have also derivation of the state space analysis of equation, that is input, and lastly we have to discuss the output equation. I just recall them, and then we have to continue our next part also. Okay, so chapter name is state space analysis. So my whiteboard is visible, everyone?
Yes, sir.
Okay, so I just recall them. So first we have to discuss that is the state variable. You know that in our state space analysis we have to use it. There are the n number of variables. Okay, so n number of variable we have to consider, and we have to name these equations. That is a variable. You know that that is x1, x2, x3 dot dot, that is a xn. So now when you have to uh, write the state variables in the matrix form, that is state variable in matrix form, you know that. So this is the xt, this is equal to the symbol of matrix, that is x1t, x2t dot dot infinite range, that is also xpt or xnt. So these are the same things, you know that. So here this xt it denotes the state vector, you know that, while x1t, x2t, etc. are the state variable that are forming state vector. Okay, so you have to know, in last classes we have to discuss. So this is the basically state vectors for the different state variables in matrix form. We have to express in this pattern. Next we have to also discuss the state variable. So we have to go the next page, just wait. State variable, sorry, this is not variable. Variable we have to cover in first page. This is state model. Okay, this is state model. So you know that in our linear system we have to, here we have to consider two inputs. You know that two or more inputs we have to attach in a MIMO system. First classes we have to discuss, this is a one MIMO system, that means multiple input multiple output system. So when you have to consider for state space analysis for a discrete time control system, you have to obviously this attach into the MIMO system. That means you have to attach the multiple input as well as to the multiple output systems. Okay, so we have considered here that is considered a linear system with two inputs that is first one we have to consider u1t and another one u2t, while two outputs that is also y1t, another y2t. Okay, so what is the basic block diagram? You know that I am drawing a block diagram. This is a MIMO block. MIMO means, you know, that is multiple input, multiple output. This is the MIMO system, and here we have to given two inputs, that is also u1t, another one is u2t, and output is given here. First one, that is the y1t, another one, that is y2t. So this is the basically outputs, and this is the basically inputs. And we have to consider here this input and output system we have to control by the state variable. So state variable we have to attach here. So x1t, another one x2t. So this is the state variables. Okay, so this is the basically state model. Okay, so ये क्वेश्चन आप लोगों को आ सकता है, draw the block diagram of the state model. Okay, तो तभी आपको ये वाला block diagram draw करके इसको describe करना पड़ेगा. So up to this part it is clear all of you?
Yes, sir.
Please respond. Is it clear? No one is response. 18
Yes,
students are right now.
Yes, sir.
Yes, Subhasis and Richika responses. Okay. So next we have to derive a state equation from this state model also. Okay. So this is very, very important. So another new questions or another important questions. What is state equations? Okay, or how it is derived? तभी आपको ये वाला derive करके दिखाना पड़ेगा. So terms is state equation. We know that state variables show variation with time. Okay, you know that this is time being oriented linear systems. So thus writing the differential equation of the state variable we will have the differential equations. First we have to consider for our two state variable x1 and xt, and it is also changes according to the time also. So that is d dt of x1t, and it is also expressed here that is x1 single dash x1 dash t, and it is a11 x1t plus a12 x2t plus b11 u1t plus b12 u2t. Okay, so this is the basically first differential equations for the first state variable, that is x1t. Another one, that is d dt of x2t. This is also expressed same as, that is x2 dash t. Okay, so this is a21 x1t plus a22 x2t plus b21 u1t plus b22 u2t. So this is the basically two state variable differential equations, and it is also changes with the time. Okay, now we have to write this differential equation in the matrix form. Okay, so now we have to represent, now we write in matrix representation. Okay, so first this is the x1 dash t, x2 dash t. This is equal to, first you know that I am previous classes we have to see, that is a11 a12, that's like this pattern, a11 a12, then a21 this one, then a, sorry, this is a21. Okay, this is a21 a22. It is also variable of, you know, that is x1t, another one is also x2t. Okay, this part it is completed. Another next part, this one, so plus that is also b11 b12, then b21 b22. Also this is the u1 t, and another one is the u2. So this is the basically matrix form of the two state variable of x1 and x2 we have to represent here. Okay, up to this part it is clear. Now you have to prepare the generalized form of this matrix form. So therefore the generalized form that is x dash t, this is equal to a of xt plus b of ut. So this is the generalized form of the input variable for the state space analysis. Okay, so please note down it. This is the input form. This is the input equation I am written here. This is the input equations of the two input, that is x1t and x2t variables in the matrix form of the state space analysis. Okay, is it clear?
Yes, sir.
Okay, so next we have to calculate the output equations. Output equations. So you know that we have to consider in our previous diagram, output is y1t and y2t. Okay, so the output of the system will be represented as the linear combination of the state of the system and the applied input. Applied input. This is given as. Okay, so now we have to prepare the output of the equation in the differential functions. That is y1t. This is equal to, you know that, c11 x1t plus c12. This is c12 x2t. Another one, d11 e1t plus d12 u2t. Okay, so this is the first output differential equations for y1t. Another one, you know, that is y2t. This is same for previous one, that is c21 x1t plus c22 x2t plus then d21 u1t plus d22 u2. Okay, so here you can see this c and d. This is a basically constant term. So the coefficient c and d taken over here are constant. Okay, so now you have to prepare, this is the matrix form. So we have to prepare these two equations in the matrix form. Okay, is it clear, all of you? Now the matrix form of output equation we will write, this is same as, you know, two input, that is y1t, another one y2t. So first, you know that coefficient of c, that is first one c11 c12 c21 c22. Okay, so this is the basically x1t and x2t. Okay, another one coefficient of d, you know that, so this is d11 d12, then also d21 d22, coefficient of that is also u1t, another one u2. Okay, so this is the matrix form of the output equation of the given system. Now therefore in general form we can write as, that is output equation, that is yt is equal to c of xt plus d of ut. So this is the output equations for the given system. Okay, is it clear, all of you? So now the important terms. So we have concluded this given questions, that is the two equation combinedly form the state model of the linear system, This is very important question. So this is a linear system. So आपको ऐसे भी क्वेश्चन दिया जाएगा प्रीवियस ईयर में, आप अगर आप लोग देखोगे, मतलब दूसरा कोई यूनिवर्सिटी का, तो देखोगे इसमें ऐसे क्वेश्चन आएगा, describe or derivation of the state model of linear continuous time system. तभी आपको, जो मैं पहला सीट से लिख रहा हूं, ऐसे स्टेट मॉडल को यहां से आपको ड्रॉ करके, जैसे इनपुट फंक्शंस दैट इज स्टेट इक्वेशंस, इनपुट के लिए, आउटपुट के लिए जो स्टेट इक्वेशन है उसको मैट्रिक्स फॉर्म लिखना पड़ेगा, बट फाइनली सो वी हैव टू डिराइव द इक्वेशंस, यू नो, that is also x dash t, this is equal to a of xt plus but, another one yt, this is equal to cxt plus du. Okay, so this is the input and output state equations for the linear discrete time system. Is it clear, all of you? Please respond everyone. Is it clear? Ankita Kumari, is it clear? Ankita, Anima, Ansu.
Yes, sir.
Yes, sir.
Okay, so please respond everyone. आप लोग मतलब चुपचाप बैठ जाते हो, कुछ भी रिस्पॉन्स नहीं देते हो, आप तो क्वेश्चन नहीं कर रहा है, हम तो सिर्फ इसको एक एक करके मतलब उसको डिराइव कर रहे हैं, तो तभी आपको बोलना पड़ेगा सर ये इट इज क्लियर और नॉट क्लियर, तभी हमको जाके मतलब यही हम लोगों का फीडबैक है. ओके, आई थिंक इट इज क्लियर ऑल ऑफ यू. So now, so this is very important questions. So please, everyone, please, I am sharing this class note in your Google Classroom portal. So everyone, please prepare it also. So in our another questions in your syllabus, there are the types of state models. There are the lots of state models are available. Okay. So before going the state model, we have to derive another block diagram of a linear time invariant system. So I am going the another one, another question. This is the block diagram. Block diagram of the linear time invariant discrete time control system represented in state space. ऐसे आप लोगों को क्वेश्चन दिया जाएगा. So what is the question? Question is draw the block diagram of the linear time invariant discrete time control system represented in the state space model. Okay. So I am drawing the pictures. So this is same as when you have to learn learn in the first control section, control part. So we have to discuss the transfer functions. So using this transfer function, it is very much easily. So first, this is the first blocks. H, this is the input. U of k we have to represent here. Then first summing point, you know that. Then this is the basically first Z inverse I, and this I it is also changes, you know that. This I is equal to 1 to n. Okay, so this is the basically changes of different block, Z block. Okay. Next, one controller blocks we have to attach here, which is control the overall process, you know that. Then another one summing point we have to attach. This is summing point, positive. Here positive we have to attach another loops here. Uh, this is expressed for the D, and it is connected this input to the final summing point from here, and this is the output sections. This is the y of k, and another plant or another blocks we have to attach process or plant. This is the basically here x of k, this one, and it is also attached this previous summing, and this is the signal of x of k plus 1 first step. When k is equal to first 0, then 1, then 2, this k is also equal to changes, you know that. This k is 0, 1, 2 dot n terms, that is the infinite ranges also. Okay, so this is the basic block diagram of the linear time invariant discrete time control system in the state space model. Okay, so ये block diagram आप लोगों को एग्जाम में आ सकता है. Okay, so this is clear. So this is a feedback loop. I am repeats once again. This is the input section. This is the output section. You know that. This is a basically D and C. This is a basically one another blocks we have to attach. That is also C is also here controller part, which is control the overall process, and H is the basically feedback part. It is also attached one summing point to the Z block also. This I it is also changes. This I is valid for the 1 to infinite range. So I is also changes, you know that. G is the processor plant, which is connected this one to the this summing point also. So then the given output term we have to calculate it. Yeah. So the transfer function, you know that, that is output to the input, that is yk by uk. Okay, is it clear all of you? Is it clear?
Yes, sir.
Okay. So in this picture here you can see we have to draw discrete time signal. Now we have to draw another that is the continuous time signal. So we go the next diagram, that is block diagram. Of the linear time invariant continuous time control system represented in state space. In state space. Okay. Previous one we have to draw for the discrete time control system, and this one is for the continuous time input signals. So this is the basically same I am drawing here. First input we have to given here. The block is also B is present here. First summing point, positive. This is summing point. Okay, this circular space. This is the input, you know, UT. Another block. This is for the integration of dt. So this is for the continuous time, that is summation of different timing schedules. Okay. Then another blocks we have to attach, that is C. Then another summing point plus then this is the finally output yt. And another processor plant we have to attach here, that is A. It is connected this one to this function. This is positive. Okay. And another block, this is D, which is connected. Sorry, this summing point to the input signals. Okay. So this is the x dot t. This x dot t we have to present state space model for the first input. This is the xt. Okay. So this is the basically block diagram of the continuous time of control system represented in the state space model. Okay, so this is the basically difference between, here you can see integral of the summation of dt, okay, with respect to the timing, and another we have to previous one we have to attach for the z transform of the different variable z transform, that is z inverse of I. So this is for the discrete time control system. Each and every sampling period we have to express using these systems also. Okay, so these two diagram, it is very much important for the state space model. Okay, is it clear all of you? Okay, everyone, write your own name and roll number in the chat box also. Pranab is present. Pranab. Neeraj. Neeraj, are you hear me?
Yes, sir.
Neeraj, you take a screenshot, okay? And after ending the class, you have to send me my WhatsApp. And another class also you have to join, okay? Because the time is 5 minutes, 6 minutes. Okay, next part, just starting. Now we have to consider for the different state models. Okay, so we have to go the next one, next page. State space representations. State space representation of discrete time system. Okay. So in our discrete control system, this system, it is basically classified into different categories. So first we have to express the canonical form canonical forms for discrete time state space equation. So we have to apply many techniques for available of the obtained for the state space representation in the discrete time control system. So we have to consider consider the discrete time system are described by, that is the equations y of k plus a1 y k minus 1 plus a2 y k minus 2 plus dot 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 plus n number of terms a in y, that is k minus a. Okay, so this is equal to, first part is, that is input part, another one is the output part, that is b0 u of k plus b1 u k minus 1 plus dot dot in number of terms b and u k minus a. This is equation number 1. So this is the basically canonical form of equation for the discrete time control system in generalized form. Okay, where this uk is the input signals and yk is the output signals, and it is also range is the number of k, that is a k sampling instant also, and here coefficient of uses, that is coefficient that is a of I, that is I is equal to, within bracket, that is I is equal to 1 2 number of n, and that is b of j, where j is equal to 0 1 2 dot dot number of n. Okay, so this is the basically general form of the canonical form of the discrete time as state space equation. Okay, so now we have to consider these two equations in the
और
transfer
तुम्हारा
function.
नहा लिया का
Yes.
तो अभी 14 बजे तो किधर है अभी तक अरे तो
Yes,
लोग इतना लगा ली
MD
मांग
Savage, please. Any questions, MD Savage?
लगा ले इधर ही
Any question or otherwise
ना
move
लगाई
yourself. Okay, so now we have to express this equation in the transfer functions. You know that transfer function, but this is the ratio between the output to the input. So that is yz by uz. B0 plus b1 z inverse plus dot dot bn z inverse n minus n, and divided by 1 plus a inverse z inverse plus